Welcome to this explainer. Today, we're totally demystifying right-angled trigonometry and, honestly, building your ultimate mathematical toolkit. If you've ever stared at a triangle and wondered how on earth to unlock its secrets, maybe for a geometry exam or just figuring out how tall a building is, you are in the exact right place. We're going to break it all down, make it super visual, and most importantly, make it stick.
So here's our flight plan for today. We'll start by meeting the right-angled triangle, then we'll unlock the magic of SOH-CAH-TOA, apply angles in the real world, learn to navigate with bearings, and finally wrap things up with some pro tips for exam success.
All right, let's jump right into part one. Meet your right-angled triangle. To kick things off, we really need to get familiar with the anatomy of this specific shape. The absolute defining feature, the whole reason we're here, is that it always features exactly one 90-degree angle. And from there, we find our anchor, the hypotenuse. It's literally always the longest side, and it's always sitting directly across from that 90-degree angle. No matter how you rotate or flip that triangle on the page, the hypotenuse never, ever changes its identity. Find the right angle, look straight across, and boom, you've found your H.
Next up is the opposite side. Now, unlike the hypotenuse, this one is completely relative to your chosen angle, which we usually call theta. Once you pick the angle you're working with, the opposite side is, well, exactly what it sounds like. It's the side on the far end, all the way across the triangle, staring right back at you.
And finally, we have the adjacent side. Adjacent is just a fancy way of saying next to. So this is the side right next door to your chosen angle, theta. Think about it. Your angle is actually touching two sides. One is that hypotenuse we already locked down, and the other is this adjacent side. Together, the hypotenuse, opposite, and adjacent form our fundamental trio, the whole shebang.
Moving right along to part two, the magic of SOH-CAH-TOA.
Now that we've got our sides down, let's pull out the primary multi-tool for this entire explainer, the literal magic of SOH-CAH-TOA. Honestly, this is the phrase that pays in trigonometry. The absolutely crucial point here is that these three simple acronyms are the keys to unlocking any side or angle you need to find. SO stands for sine of theta equals opposite over hypotenuse. CH means cosine of theta equals adjacent over hypotenuse. And TOA means tangent of theta equals opposite over adjacent. If you just memorize these three little formulas, you've essentially memorized the entire core rubric of right-angled trigonometry. Let's actually test this tool out on a practical, real-world problem. Just imagine a ladder, a 10-meter-long ladder, leaning up against a wall. Now let's say it makes a 30-degree angle right there with the ground. So how high up that wall does the ladder actually reach? Okay, first things first, we identify our sides. The ladder itself, that's our hypotenuse, 10 meters. The height up the wall is opposite our 30-degree angle. So, because we want the opposite and we already have the hypotenuse, we look at SOH-CAH-TOA and choose SO, sine, right? So the sine of 30 degrees equals our unknown height divided by 10. The sine of 30 degrees happens to be a clean 0.5, so we just multiply 0.5 by 10, revealing that our ladder reaches exactly 5 meters high. Simple, incredibly logical, and highly effective. But hey, let's push into slightly more complex territory here. What happens when we completely flip the script? Suppose we actually have the side lengths, but we are totally missing the angle itself. Let's say our opposite side is 8 centimeters and our adjacent side is 6 centimeters. What exactly is our angle? Theta. Looking back at our toolkit, we have opposite and adjacent. And you know what that screams? TOA, tangent. So the tangent of theta equals 8 over 6. Now to isolate theta, we have to use the inverse tangent function on our calculators. Theta equals the inverse tangent of 8 divided by 6, which yields an angle of approximately 53.1 degrees. How cool is that? You literally just used two physical sides to discover a totally invisible angle.
Which brings us to part three, angles and the real world.
So now that we've mastered our toolkit, let's take these concepts outside the classroom and into physical space. Because how do we actually describe these angles when we're out in the wild? Well, it all really comes down to where you're standing and where you're looking. If you're standing on the ground looking upwards, say at the top of a giant tree or an aircraft flying by, you measure upwards from your horizontal line of sight. This is your angle of elevation. Conversely, if you're already elevated, maybe you're up in a lighthouse looking down at a little boat, hopefully not dropping anything on it, you measure downwards from the horizontal. And that right there is your angle of depression. And this brilliantly illustrates a truly beautiful geometry shortcut. Picture this. One person is on the ground looking up at that lighthouse, and another person is up in the lighthouse looking down at the ground. Their horizontal lines of sight are perfectly parallel to each other. Because of this, the angle of elevation is mathematically identical to the angle of depression. They're alternate interior angles. So it's basically a 2-for-1 deal. If you know one, you automatically know the other. All right, let's keep the momentum going with part 4, navigating with bearings. Let's push our skills even further and see how we can actually navigate ships across oceans and airplanes through the sky using bearings. Now, bearings are a very specific way of communicating direction, and they follow strict rules. They're always measured clockwise, and they always start from north. Plus, they absolutely must be written as 3 digits, meaning northeast isn't just a casual 45 degrees, it is written precisely as 045 degrees. East is 090 degrees, south is 180 degrees, and so on. I know bearing problems can seem intimidating, but whenever you encounter one, don't panic. Just follow this super simple, foolproof 4-step procedure. First, draw a north line pointing straight up. Second, measure and mark your given bearing clockwise from that line. Third, just turn that path into a right-angled triangle. And finally, fourth, reliably apply your SOH-CAH-TOA skills to map out your exact distances or coordinates. It works every single time. And finally, we arrive at part 5, pro tips for exam success. To wrap up this explainer, I really want to equip you with the essential tips and highlight some common pitfalls so you can absolutely crush your upcoming exams. Often, you actually won't be allowed to use a calculator. You'll need to know the exact trigonometric values for standard angles, 0, 30, 45, 60, and 90 degrees. Memorizing this specific table will save you so much crucial time. And definitely notice the patterns here, like how sine steadily increases from 0 to 1, while cosine does the exact opposite, decreasing from 1 to 0. Lock these fractions and square roots into your memory. It is a total game changer. Beyond the math, setting yourself up for success is as simple as strictly adhering to 4 foundational habits. Before you even think about writing down an equation, label your O, A, and H directly on your diagram. And hey, if a question about elevation, depression, or bearings doesn't actually give you a diagram, draw one. Seriously, draw it out. Also, always double-check whether you're hunting for a side length or an angle. And lastly, never ever forget to include your units in that final answer. On the flip side, avoiding the incredibly common mistakes is just as important as knowing the math itself. The absolute biggest offender, forgetting to put your calculator in degree or DEG mode. I cannot stress this enough. If your calculator is in radians, literally all your answers will be wrong. Other traps to watch out for include picking the wrong adjacent side, using sine when you clearly needed cosine, mapping elevation instead of depression, or just being lazy and writing a bearing as 45 instead of 045. Just stay sharp on these little details. And there you have it. You've successfully identified your triangle, mastered the SOH-CAH-TOA toolkit, scaled buildings with elevation, navigated the seas with bearings, and built up your exam defenses. Now that you've got the foundational rules of right-angled trigonometry down pat, you are entirely prepared to tackle whatever geometry problems get thrown your way. The only question left is, with SOH-CAH-TOA securely in your mental toolkit, what complex real-world mysteries will you unlock next? Thanks so much for joining this explainer, and keep exploring.